Somewhere beneath the waves, a predator moves that answers to no one. It is powerful enough to flip a great white shark onto its back and hold it there until it drowns. It is coordinated enough to surround the largest animal that has ever lived on this planet, the blue whale, and bring it down through teamwork alone. And in recent years, it has done something no marine biologist predicted. It has learned to sink boats off the coast of Europe, snapping steel and fiberglass rudders like they were nothing, and yet, in the entire recorded history of human interaction with this creature in the wild, there is not a single confirmed case of it killing a person. Not one. Think about that for a moment. This is an animal with a bite force capable of crushing bone, a body mass rivaling a city bus, and a hunting intelligence so refined that it coordinates attacks like a special forces unit. By every law of predator behavior, when a soft, slow, defenseless human enters its territory, that human should be prey. Easy prey. And yet, time and time again, divers, surfers, and swimmers report the same bizarre encounter. A massive black and white shape gliding past, pausing, observing, and then simply swimming away. Why? Why would the ocean's most lethal hunting machine, an animal engineered by millions of years of evolution to kill efficiently and without hesitation, voluntarily cross humanity off its menu? The answer isn't luck, it isn't coincidence, and it isn't fear. It's something far stranger. Something buried deep in the biology, the intelligence, and the culture of this animal. A species so complex that understanding it will force you to rethink everything you thought you knew about power in the natural world. To understand why the ocean's deadliest predator has chosen mercy, we first have to understand what and who this creature really is. Because the name we've given it has been wrong from the very beginning. For centuries, humans have looked at this animal with pure dread. The Roman naturalist Pliny the Elder once described it as an enormous mass of flesh, armed with savage teeth, a monster from the deep. That fear didn't come from nowhere. It came from watching the animal do exactly what it was built to do: hunt with terrifying precision. Centuries later, Basque and Spanish whalers watched pods of these creatures surround and take down massive baleen whales in open water. Struck with fear, they gave them a name: Balena assassina, whale killer. When the phrase crossed into English, something got lost. The words flipped. Whale killer became killer whale. And in that small linguistic accident, an entire species was rebranded as a mindless, murderous beast. But here's the truth. It isn't even a whale. Taxonomically, the orca is the largest member of the oceanic dolphin family, Delphinidae, a branch within the order of toothed whales, Odontochaetae. Its scientific name, Orcinus orca, traces back to Orcus, the Roman god of the underworld, a fitting name perhaps, but not for the reasons early sailors believed, because evolution didn't build this animal to be a mindless killer. It built it to be something far more sophisticated, a perfectly engineered apex predator shaped by millions of years to dominate every ocean on Earth. A mature male can stretch nearly 10 meters long and weigh up to 10 metric tons, roughly the mass of a loaded city bus. Rising from its back is a dorsal fin that can tower almost 2 meters tall, built entirely of collagen with no supporting bone, doubling as both a rudder and a thermal radiator during high-speed pursuits. But its most fearsome feature lies hidden behind a curved, confident smile, rows of interlocking teeth, each roughly 10 centimeters long, capable of shattering bone in an instant. This is an animal with no natural predator, no equal in the sea. So why does it wear a coloration so bold, so visible, so seemingly impossible to hide? The black and white pattern that makes the orca instantly recognizable isn't a design flaw. It's one of the most sophisticated camouflage systems in the natural world, a technique known as countershading. In the layered light of the open ocean, this coloring becomes an optical trick. Seen from above, the orca's jet black back dissolves into the darkness of the deep water below. Seen from beneath, its stark white underside vanishes into the shimmering light of the surface. The scattered white patches along its flanks do something even more unsettling. They break up its outline entirely, making it almost impossible for prey to judge its true size or direction until it's already too late. Occasionally, nature throws in an exception that defies explanation altogether. In 2012, researchers off Russia's Kamchatka Peninsula documented a fully grown male orca with a rare albino mutation, an entirely white animal they named Iceberg, a ghost drifting through Arctic waters. But coloration is only part of the story. What truly sets this predator apart is its staggering adaptability. Aside from humans, no other mammal on Earth occupies as much territory. Orcas patrol the freezing waters of Antarctica, glide through the coral reefs of Hawaii, and cruise the Arabian Gulf, where surface temperatures can climb past 30 degrees Celsius. This is possible thanks to a blubber layer up to 10 centimeters thick, paired with a vascular system that can expand or contract on command to release or trap heat. Fueling this enormous adaptable body requires an enormous appetite. An adult orca consumes roughly 135 kilograms of meat every single day. A demand so relentless, it has turned this animal into one of the most versatile hunters on the planet, preying on more than 140 different species. From schools of herring to armored sea turtles, from penguins to dolphins, nothing in the water is entirely safe. But 2 entries on that menu shouldn't be possible at all. For years, marine biologists in South Africa were baffled. Great white shark carcasses kept washing ashore, fully intact except for one detail. Their bellies had been torn open and their livers were missing. The culprits, it turned out, were orcas. They had discovered a devastating biological weakness. When flipped upside down, sharks fall into a state called tonic immobility, a kind of neural paralysis that leaves them unable to breathe. Orcas exploit this ruthlessly, ramming a shark's flank at full speed, flipping it over and using their teeth to extract the liver, an organ rich in squalene, the most calorie-dense fuel source available in the entire ocean. In parts of Australia, the fear runs so deep that great white sharks will abandon entire stretches of coastline for months the moment they detect orcas nearby. But there is one act of predation that, for decades, existed only as a terrifying hypothesis: an orca pod killing a blue whale, the largest animal ever to exist on Earth. Then, in 2019 and again in 2021 off Bremer Bay in Western Australia, scientists finally witnessed it firsthand. Pods of orcas moved with the precision of a trained military unit, taking turns holding the blue whale's blowhole underwater to suffocate it, while others tore at its flanks and targeted its tongue. It confirmed what researchers had long suspected. There is no prey too large for this predator. But brute force alone doesn't explain hunts like the ones seen in Antarctica, where orcas swim in tight formation to create a single coordinated wave, washing a resting seal clean off an ice floe. It doesn't explain the intentional beaching technique used at Argentina's Valdez Peninsula, where an orca launches itself onto dry sand to snatch a sea lion pup, then wriggles back into the surf, a skill so dangerous it must be taught patiently over years by a mother to her calf. This isn't instinct, this is strategy, and it means something else entirely is at work inside this animal's mind. To coordinate hunts this complex, to pass down beaching techniques across generations, to recognize the sound of a fishing boat's winch from kilometers away, an animal needs more than instinct. It needs a remarkable brain. And the orca has one. An adult orca's brain is roughly 4 times larger than a human's. When scientists ran MRI scans on orca brains, they found something extraordinary. Densely folded tissue in the regions responsible for emotional processing, along with networks of spindle neurons. The same specialized cells linked in humans to empathy, intuition, and grief. Orcas are also among the vanishingly rare group of animals that pass the mirror self-recognition test, a benchmark scientists use to identify genuine self-awareness. Because they possess a sense of individual identity, orcas even have something resembling names. Within its first weeks of life, a newborn learns the unique acoustic signature of its family line, a sound it will carry and broadcast for the rest of its life, announcing to the ocean, "I am here. I belong to this family." This depth of cognition has pushed orcas beyond simple survival instinct and into something closer to culture. In the Pacific Northwest, 2 distinct populations share the exact same waters yet never interact. One group, the residents, feeds exclusively on salmon. The other, the transients, hunts marine mammals. They don't interbreed, they don't share hunting grounds, and their vocal dialects are so different that a resident pod literally cannot understand a transient pod, the acoustic equivalent of 2 people speaking entirely unrelated languages. None of this is written into their DNA. It is taught, learned, and passed down generation after generation. Even play reflects this complexity. Orcas have been observed tearing long strips of kelp from the seafloor and draping it across their bodies, rubbing it against their fins in a behavior researchers call kelping. Once thought to be parasite removal, now understood as pure recreation. Holding this entire cultural structure together is an unusual social system. One led not by the strongest male, but by the oldest female. And buried within that matriarchy is one of the strangest mysteries in all of evolutionary biology. In most species, an organism that can no longer reproduce is gradually phased out by natural selection. But female orcas break that rule entirely. Around age 40, they stop reproducing, and then continue living for another 30 to 40 years, not to rest, but to lead. The most famous example is Granny, designated J2, one of the longest-lived orcas ever documented, reaching an estimated age of nearly 80. For roughly half her life, her only role was guiding her descendants. Scientists call this the grandmother hypothesis. By stepping back from reproduction Older females avoid competing with their own offspring for food and instead become living archives, carrying decades of memory about migration routes, hidden currents, and safe waters during deadly storms. Pods led by these grandmothers have measurably higher survival rates during the harshest, food-scarce years. This is a family structure built on devotion, and in the summer of 2018, the world watched exactly how deep that devotion runs. On July 24th, 2018, a southern resident orca named Tilikum, designated J35, gave birth to a female calf. The infant lived only 30 minutes. What happened next stopped the world. Tilikum balanced her calf's nearly 180-kilogram body on her forehead and began to swim. Whenever the small body slipped beneath the surface, she dove down and pushed it back up again and again, refusing to let it sink. She stopped eating. She ignored her own exhaustion completely, and she carried her daughter's body through the ocean for 17 straight days and nights, covering more than 1,600 kilometers. She wasn't alone. Other members of her pod swam beside her the entire journey, taking turns supporting the calf's weight whenever Tilikum could no longer hold on. Neurobiologists point to this as undeniable evidence of grief, a psychological anguish that crosses the boundary between species, proof that these animals love their families with the same intensity we do. It's this same emotional depth, this same profound intelligence that finally begins to explain the greatest mystery of all. Why has a predator this powerful, this intelligent, capable of killing a blue whale, never killed a single human being in the wild? When you enter the ocean, you are, biologically speaking, defenseless. No armor, no venom, no claws. By every measure of predator logic, you should be easy prey. And yet orcas glide past divers and swimmers constantly, pause, observe, and swim on. Many assume this is a case of mistaken identity. The same reason great white sharks sometimes bite surfers, confusing a silhouette for a seal. But that explanation doesn't hold for orcas, because orcas don't primarily rely on sight. They rely on echolocation, a biological sonar so advanced it can see straight through skin. When those sound waves bounce off a human body, they return detailed information. Our bone density, our lungs, and crucially, the almost complete absence of the thick blubber layer that defines a seal. The signal is unmistakable. This is not prey. But even the most advanced sonar has blind spots. In churning surf, millions of air bubbles scramble the signal entirely. This is exactly what happened in 1972 off the coast of California, when a surfer paddling through turbulent whitewash was suddenly seized by the leg by a hunting orca relying on sight alone. It had the power to end the encounter instantly. Instead, the moment its teeth registered the wrong bone structure, it released him immediately and swam away. A stunning act of split-second restraint. That same restraint may explain the wave of incidents rattling the coast of Spain and Portugal since 2020, where orcas have rammed and disabled the rudders of more than 673 boats. Some vessels have sunk entirely. But even as panicked sailors fall into the water, the orcas never touch them. Their focus stays locked entirely on the rudder. Researchers believe this is a cultural trend among roughly 15 young orcas, a form of play or practice, spreading exactly the way a trend spreads among human teenagers. No matter how it looks, the rule never breaks: never harm the human. But that peace treaty has a dark exception, and it was written entirely by us. Picture an animal built to swim over 100 miles a day alongside its family, guided by sound, memory, and culture passed down across generations. Now picture that same animal locked inside a concrete tank barely a few body lengths wide. The result is a documented psychological breakdown scientists call zoochosis. In captivity, an orca's own echolocation clicks slam against smooth concrete walls and bounce back amplified, like being trapped in a closet, forced to listen to your own screams echo endlessly. Marine parks routinely place orcas from entirely different oceans and cultures into the same enclosure. Animals who share no common dialect, forced into permanent, inescapable proximity. The result is violence, deep scarring from tankmate aggression and self-destructive behavior so severe that captive orcas grind their teeth down to the pulp, requiring dental drilling performed fully awake without anesthesia. Nearly every mature male in captivity develops a collapsed dorsal fin, the boneless collagen structure sagging under gravity at the surface. Instead of the 80-year lifespan they'd have in the wild, many die by 20. No story illustrates this collapse more brutally than Tilikum. Captured off the coast of Iceland in 1983 at just 2 years old, and confined for over a decade in a pitch-black module barely 6 meters across, locked away more than 14 hours a night to prevent him from being torn apart by aggressive tank mates. Over 34 years of captivity, Tilikum was linked to the deaths of 3 people, including trainer Don Brancho in 2010. These were not the split-second mistakes of a confused predator. They were the actions of a mind broken by decades of isolation and violence. The darkest possible mirror of what we've done to this species, and the threats haven't ended with captivity. Cargo ship engines are drowning out the sound orcas depend on to navigate and hunt. Toxic chemicals accumulate in their blubber at the highest concentrations recorded in any animal. Dams and warming waters have collapsed. The salmon runs entire populations depend on to survive. And yet, out in the open ocean, the treaty holds. Indigenous communities of the Pacific Northwest, like the Lummi, have always understood this. They call orcas Quilholmechin, our relatives under the waves. Perhaps the real mystery was never why an apex predator spares us. It's how, even as we poison its home, it still chooses not to